Before we get started, a quick shout out to Mr. Thomas Pan. By request, a quick shout out to Mr. Thomas Pan. Okay, guys, so for number 31 here, we want to solve this system of equations. So recall that one technique involves elimination. So, for example, if you were to look at the x's, one says 3, one says -4. I'm thinking of -12 or I'm thinking of 12s actually. So watch. Why don't we multiply the top equation by 4? We'll distribute. And we'll multiply the bottom equation by 3 and we'll distribute. Let's see what happens if we do that. In the top, distribute everything with a 4. That'll become 12x minus 8y equals -48. In the bottom, distribute the 3. Minus 12x plus 15y equals 69. Now, the whole point of having done this is that now these x's cancel. If you add them, they cancel. Combine the y's, that'll be 7y. Combine the constants, the regular numbers, that'll be 21. And so 7 times y is 21. Divide by 7, and we've discovered that y is 3. We have found that y is 3. Y is 3. Write that down somewhere. Y is 3. All we need now is x. So now that you know what y is, take y, which is 3, and plug it into either of the originals. So it doesn't matter which one. Let's say we plug it into the top equation. That'll say 3x minus 2 times y, which is 3, equals -12. So this is 3x minus 6 equals -12. Let's go ahead and add the 6, add the 6. These cancel. 3x equals -6. Divide by 3, and x is -2. So we have our final answer, -2, comma 3. Try to write it as x, comma y in that order, and our answer is right there in green for number 31. Now, for 32, let us model this situation. We have a rectangle, and let's suppose that we have a length and a width. Now, we know that we went to the store and we purchased 150 feet of fence. And let's assume we want to use all of it. So to do that, you're going to need 2 lengths plus 2 widths, and that'll produce 150 feet of fence because we're going to use all the material. So this is an equation. And right away, I noticed that I can make this equation look simpler. We can divide everything by 2 to simplify this equation. So that would say that 1 length plus 1 width equals 75. And that makes sense because the length and the width is halfway around, and halfway to 150 is 75. Now, another fact is here. The length is twice as long as the width. It's longer than it is the width. So watch. Here in red, if I were to say that length equals width, that would be false. I would be a liar because that's not true. It turns out that it's twice as long as it is tall. So it is true that if I were to double the width, that would equal the length. That is a true fact. So that creates another equation. So I have this equation here, and I have this equation here. It's basically a system of equations that we just solved. So I have 2 equations. We have this blue one, and then we have this blue. So solve this equation however you'd like. Here is an option. How about you take 2w, which is L, and place it right there for L. So that would say 2w plus 1w equals 75. Well, 2w's plus 1w is 3w's. 3w's equals 75. That implies that w is 25. W, the width. The width is 25. This is 25. Now, the length is twice as much. So the length would have to be 50. And we're pretty much done because the goal was to find the dimensions. You got them. 50 by 25. So maybe you can say something like 50 feet by 25 feet as your final answer. So for 33, we need some facts. Let's say you have some equation or some picture called g of x. What would g of x plus 1 do? What about g of x minus 1? What about g of x plus 1? What about g of x minus 1? What about negative g of x? What would these things, how do these manipulate the original? Let me tell you. So g of x plus 1, it's going to move the original picture one space to the left. G of x minus 1, that'll move the original picture one space to the right. G of x plus 1 outside, that moves the original picture one space up, and this guy moves it one space down. Now, what if you put a minus sign outside? That will reflect or flip it. That'll reflect the original picture vertically. So with all these things in mind, let's see if we can modify this original graph here. Now, the order does matter. The order of these, they're called transformations. So if I have negative, parentheses, x minus 2 plus 3, the first move would be this guy. That's the first move. And that would be the second move. And this guy, that is your third and final move. So let's see if we can move this original picture according to all of these moves. So let me go yellow here. Yeah, this will work. So first move is to do this first. Do g of x minus 2, which, as we just said, would move something two spaces to the right. So take this original green thing, move it two spaces to the right, and roughly speaking, that would be like something like that, two spaces to the right. That's what that first move does. The first move, two spaces to the right. What's the next move? The second move is to do this. That is going to make something flip vertically. So instead of like that, it'll be upside down. So what would that look like? Let me now go to orange. So now take the yellow and flip it vertically. Well, that would look something like this. That would look something like, let me try that again. That wasn't too good. Yeah, that's not too good either. A little better, a little better. So our second move, our vertical reflection, that's the orange. That's the orange. That's the orange. Now your third and final move is to bump the orange up three spaces. So right now it's at a height of 2. So it would be like way up here at a height of 5. So I would put that on my final answer here in this blank page here. So notice it's already set for a height of 5. So that would be something like that. You see that? So the order matters. Always do this guy first, and then do that second, and then do this last. And it's good to show like different colors to show how you progressed from the start to the end. Okay, final part here. So here we have this function called f, and here we have a picture of a function called g. Part A says g of 1. So go to equation g, right? So go to equation g, which is this guy here. Now, g of 1 means go to 1 on the x-axis. And then you're at 1, and then go to the graph, which is actually right there where you are currently standing. So what is the y-coordinate there? The y-coordinate is 0, which is why that is the final answer for part A. It would just be 0. What about for part B? That's the goal right there. Well, you could separate that to make it look like this. That could say g of negative 2 over f of negative 2. So let's see what these guys are independently or individually. So g of negative 2. Equation g is the picture. Go to negative 2 on the x-axis. Go to the graph, and what's the y-coordinate? 1, which is why it says 1. What about f of negative 2? Go to column, go to table f, go to the x's, find negative 2, that's the input, and the output would be negative 3. And you're done. There's nothing else to do, so you're done with that part for part B. How about part C? Well, the key here is it says inverse. So if it says inverse, you're not going to go from left to right. You're going to go from right back to left whenever it says inverse, like that. So for that one, go to table F, which is this guy. But since it's inverse, you're going to find 2 on this column. And I see 2 right there. and then go back to the other side, and that would be 3. So that's how that works out whenever there's a little inverse symbol for part C. What about part D? So here we have G of F inverse of 2. Well, we just discussed that F inverse of 2, yeah, we just found it. F inverse of 2 is just 3. So inside, that can just become 3. And all that's left is to go G of 3. So go to picture G, plug in 3 right there, go to the graph, and what's the y coordinate? 2, which is why this answer would just be 2 for part D. And then E and F are the same thing. So look, for part E, if you separate it, it would say F of 2 plus G of 2. Find F of 2. That looks like it's going to be 1. Find G of 2. That looks like it's going to be 2 for a final answer of 3. And then finally, for part F, we want F of G of -4. So do the inside first. How much is G of -4? Find G of -4. So G is the picture. Go to -4 on the x-axis. Go to the graph, and what's the y-coordinate? -1. So the inside becomes -1. Now find F of -1. It looks like the table says -2, and that would be your final answer.